we appreciate you coming at lunchtime. I'm sure everybody will be ready for lunch, but we appreciate that you're coming to spend some time to talk about this important topic of circularity with us. So today my colleagues, Dr. Cassandra Legaliade and Vincent Olivier, they're going to take you through an agenda about circularity, in particular with concrete in construction. So on that note, I will pass over to them. Thank you very much.
Hi everyone, I hope you can hear me well. If not, I will switch mic. So today we will present you how we can advance the construction, sustainable construction through circularity. So I will give you a short introduction of Holcim and aggregate industry. I will present you our net zero strategy and what is circular economy, and my colleague Vincent will present you how to be more circular in the cement manufacturing, and we will also show you some group initiative across the world. And finally, I will present you what is an EPD and why it is important. So first, we are part of Holcim. So aggregate industry is a UK-based company, part of Holcim. And Holcim is 60,000 employees over 70 countries. And in the UK, we are not as much. We are only 4,000 employees, and we are divided in several divisions. The first division, which I'm part of, is ready-mix concretes. We also have a cement division, which Vincent is part of. We have an aggregate division, a concrete product division, and finally, surfacing solution with asphalt products. And because of this, because we are a major player in the cement manufacturing process, and 40% of the CO2 emission in the UK are due to the built environment, we do have a moral obligation to reduce our carbon footprint. That's why we aim to decarbonize the built industry through green operation, through circularity, and through sustainable solution. So to achieve this, we have a net zero strategy that is divided in 5 pillars. The first one is climate, with the decarbonization, which we all know about. The second one is people and community, because we cannot have a net zero strategy without including the people in it, without including the community in it. And we also have nature and environment, because we need to preserve biodiversity. That's why also our fourth pillar is circular economy. And the last one is sustainable solution, because we want to give you sustainable solution to be able also to decarbonize. Our typical products have more or less CO2. So aggregate only have 6 kilograms of CO2 per ton, which is quite low compared to the cement, which for now has 730 kilograms of CO2 per ton, which is massive. And that's why our net zero strategy is in place. We have 3 targets. The first one is 2025, so only next year, where we want to reduce CO2 by a third. And then 2030, where we want to reduce CO2 by 68%, which is quite soon. And finally, 2050, where we want to have almost no CO2 emission. But today, we want to focus this presentation on the scarcity of resources, because we are using way too much resources. If we keep going like this, in 2040, we will use more than twice the resources on the planet, which is too much, is not viable. And only more than 7% of the economy is circular. So we need to move towards circular economy, because it will help saving resources, avoid biodiversity loss, and it might reduce the CO2 footprint as well in some cases, but it also ensure a future for my generation and the next generation and all generation. So circular economy in construction look like this. So you can obviously reuse alternative fuel and renewable energy from all the industry. You can reuse materials like SEM, like you have in concrete with the GGBS, for example. But we can also include circular economy in our industry by reusing construction demolition waste, or also by reusing the CO2 to cure the concrete, for example. So that's what my colleague will present to you.
Right. So yes, we have the European Commission that has made some estimation about the amount of construction demolition material that is generated in Europe every year, yeah? And the estimation is about 500 million tons. Out of this 500 million tons, is about a third, which is concrete. And you can see, just looking at the pictures, there are very different streams of material, and they present different challenges for handling. So if I take, for example, the returned concrete picture, we know exactly what it is. We can identify what's the ratio of coarse aggregate fines. We can have even which cement's been used, the cement content, the chemical composition of the cement used, so very high level of data. If you look at the skip and the material which is in the skip, it's quite different challenges to handle here. But there are different ways and different approach to use. So these different material streams. One is looking at the alternative raw material, so as a raw ingredients in order to make cement or clinker. Another one is also to replace clinker. We'll do that in a minute. Another avenue for using this recycled material is to use it as a sub-base material for a road solution, or to use also the coarse recycled concrete as for concrete ready-mix or precast solution. So we have a cement roadmap, decarbonation roadmap. The key ultimate goal is to have this carbon capture that is really the game changer. But here in this presentation, because we're focusing on circularity, I will focus on two areas, which is the ARM, alternative raw material. We love acronyms. And then the MIC stands for mineral components. So on the ARM, alternative raw material, we're looking at what kind of material streams can we use instead of virgin material in order to prevent extracting material from our own quarries. And so last year we achieved to have a substitution rate of 15%. We have at AI a target to have 3 million, to achieve 3 million of recycled materials by 2025. And as you can see in the breakdown, most of the substitution is coming from the limestone tailing. So we identified a nearby quarry where they had some some limestone contaminated with some clays that they couldn't sell to the customer, or they were managing to selling a third as a subfill. But the rest of this material that they needed to extract in order to access the limestone, they was just like landfilled in their own quarry. So by being able to utilize this material stream, then we've been able to not use the limestone for our own quarry. And we've been looking also at construction, concrete recycles, also ceramics, and we have different material streams. It comes as a challenge because each stream, the more inputs or material you bring in, it's a challenge in terms of adjustment operation for controlling the quality. And then we also had to find a source for the iron corrective, because we're not only fighting from the recycling and decarbonation point of view, we're also looking for replacing fossil fuel. So when you change the type of fuel that you're using, you change the content of the ashes, and therefore, in order to achieve the right chemistry, we need some corrective. So we're looking also at how we could integrate in the clinker manufacturing or cement manufacturing process some more recycled material streams. there are plenty of material streams. We can here this is a nice diagram how they are kind of grouped together. Different material streams comes with different challenges. For example, a lot of slag waste material, stream material tends to have brings their limitation with chromium. Sometimes paper mill ash, you need to look at from the chlorine point of view. Fly ashes could bring some heavy metals and so on. So waste utilizing recycled material streams sometimes with some challenges. So that was from the alternative raw material point of view. Now I'm going to look at more from the cement replacement point of view. So just more towards the end of the process. So what can we substitute clinker with in terms? And we have since June 2023, last year, we have this new standards been published that basically defines a new component for cement. So in cement, you can't put everything you want. There is clinker, there is limestone, pozzolan, fly ash. There are different materials which are allowed, and this standard defines a new type of material. There are some limitations, there are some constraints in terms of chemistry, so some limitations in terms of sulfate contents, TOCs, and so on and so on. But basically, what is also important is that even though we have this cement standard, we can't use it mainstream in the application because it's not yet in the concrete standard for the UK. So there is some work, hopefully, that will start, and we hope that in the future we'll be able to have main outlets from the cement perspective to use recycled concrete fines. Now I'm just going to elaborate a little bit on some group initiatives, especially on the topic of circular economy. One was a project in France. So basically they have been connecting the waste gases from a cement plant, which has about, in that case, 20% CO2 content in the flue gas, with some recycled concrete that has been crushed down and put in the fluidized bed. And there was two type of grading done. One was kind of a recycled fine sand, so 0 to 4 millimeter, and the other one more kind of a recycled gravel type, so 4 to 16 millimeter. And there was two advantages. One was looking at obviously absorb the CO2 from the stack, from the cement manufacturing process, to carbonate the aggregates. And the other one was also to improve the aggregate properties by lowering their porosity. And yeah, about 40 tons of the material was being produced, basically. And then we found that in the fine parts, the recycled fines, then more carbon footprint was captured while compared to the coarse. But this kind of aggregate can be then used in your concrete manufacturing with some limitation, and that's a way of decarbonating your cubic meter of concrete. There have been a lot of testing done on two different types of concrete, C25, C45, and basically we found that there was similar performance in terms of mechanical performance, but also fresh properties and durability. I'll go more quickly on this one. Basically, there is 100% recycled clinker also being tried in 4 different plants in France, in Poland, and in Austria. Each time it's kind of next steps. First one was, can we do it? Next one was, can we do it more economically viably? The next trial was, can we do it with achieving a higher carbon footprint reduction? So, and this clinker has also been used for this kind of projects where we have been a building being used with this all recycled material, recycled cement from recycled concrete, and recycled water, recycled aggregates. Also, I just want briefly to mention the eco-cycle. So eco-cycle, this is, you might be know about the EcoPlanet and EcoPact branding. EcoCycle is a brands from the group, all same group, where the minimum criteria is to have minimum 10% recycled material content, and it needs to be independently by a third party verified. With that, I'll leave Catherine to talk about the EPDs and the importance of verification. Thank you.
So all this is really important, but we need a tool to measure it. We need to be able to measure how much a product is circular, and we need to be able to measure how much a product is emitting in terms of CO2, so the embodied CO2. And for this, we use Environmental Product Declaration, which is called EPD. And an EPD is covering different life cycle assessments, life cycle stage. You can have an EPD that is A1 to A3, called cradle to gate. It's A1, the raw material supply. A2 is transport to the factory, and A3 is the manufacturing. You also have EPDs that are cradle to grave, so it means A1 to the end of life stage, which is the C stage. And the EPDs that we decided to work with are A1 to D, so it's called cradle to cradle, which means it goes from raw material supply until D, which is reuse and recovery. And if you ask yourself, what is the Environmental Product Declaration? It's your lucky day. So EPD is an environmental performance document, so it shows the different environmental performance impact factors. It's a type 3 environmental declaration, which is the best type of environmental declaration you can have, environmental label. And it should be where you see the 1. That's where you can see what, if it's according to the right standard, which is ISO 14025. And you have the scope of the EPD, which is in this case, one of our EPD, which is ready-mix concrete, a C3040. And the EPDs that have been done after 2019 should be according in Europe to the standard EN 15804 plus A2. So in the EPD, you find the CO2, which is the global warming potential of the materials, but you don't find only this. You find several impact factors like fresh water use, or the use of non-renewable secondary fuel, or the use of different raw materials. So that's how you can quantify how circular a product is with these different impact factors. And currently in the UK, you have different type of EPD. You have industry association EPD, which is the less accurate because it will be more of an average. In this case, if you look at EPD that are done by the MPA, you will have the average of all the all the cements in the UK, of all the manufacturers that are contributing to the MPA. Then you have the individual company EPD. So it will be for specific products, but it will be for a company, so it's on several plants, so it will be for every grey cement, in this case, or every C3240 concrete in the UK. But as I mentioned at the beginning, we have 85 concrete plants, so it will be an average of all these plants, impact factor, life cycle assessment. And finally, the last one, which is the most precise EPD you can have, is a plant and product specific EPD. So it will be for a precise product in a precise plant, and it's the most accurate you can have. To do an EPD, it takes some time, and that's why the industry is not flooded by EPD. So you start by collecting the data. So it will be the manufacturer that is collecting the data. The manufacturer is giving the data to the consultant, who is doing the life cycle assessment. And then the same consultant will run a background report. This 3-stage can take 1 to 3 months, depending on how fast you are and which consultant you are working with. And after you end this report, you give it to a third-party verifier. This third-party verifier will verify the data, verifies that the life cycle assessment is correct, and verify that the data are correct. And yeah, that they are correct. It takes 1 to 2 months, but at the moment, verifiers are being flooded with different background reports, so it can take up to 12 months, which is quite a lot. And finally, when everything is okay, it will be published by the program operator. It's the quickest stage. It usually takes 1 to 2 weeks. So in London, we publish plant and product-specific EPD for all our plant, for all our ready-mix concretes. So it's over 150 EPDs that have been published. And to give you an order, it took almost 2 years. So this project took a really long time to make it possible due to the different stage. And now we are working on having EPD for Manchester, Lancaster, and Liverpool, and Birmingham in the near future. So that's all. If you have any question, feel free to ask it. Any question?
Can I just thank you first and foremost, Cass, for your presentation, and Vincent. We've touched on some big topics in terms of circularity. You know, one of the key themes of the conference is about collaboration, and we are just one producer in what is a huge sector. So big topics that I think we need to have conversations about. So we are here for the duration of the show, which you can find us at the stand at the back. But yeah, if you've got any questions in terms of EPDs, you want to follow up with some more information, please ask now, or if not, come and see us later. But thank you both.
Hi there. I was just wondering which aggregate product offers the best supply chain, as in which is the product that you currently use that you have the most amount of? So the aggregate side of it.
So where is the source of the main aggregate?
Yeah, so you spoke about not having to excavate, you know, and you've got a supply of, I can't remember what term you used, but, you know, essentially recycled. And I'm just interested in what, out of those, which do you have the most of, as in what's not going to run out?
Okay, so we have different, we work with different suppliers. And in terms of the volume, you can see that already with 5 different streams, we achieve only a substitution rate of 15%. And out of this 15%, there are mainly a big one coming from one quarry. So it's really kind of a case-by-case thing. Also, it has to make some kind of sense economically, because you might have a big source available somewhere, but if it's too far from the cement plant, that would prevent us from accessing this material. So it's a case-by-case criteria. Yeah. Did that answer the question?
Yeah, it did. Because I'm finding that on the EPDs for stages A1 to A3, not using something that's from virgin ground dramatically reduces those early stages. But so yeah, I mean, because I'm speaking to other concrete manufacturers as well, where so Cornish Concrete get their aggregate from their China clay pits. So I'm trying to, you know, basically, how long can we use these things for, really? But yeah, no, it did though. Thank you.
Recycling material doesn't necessarily mean comes with decarbonation, because sometimes, like in this case, it was kind of replacing limestone with another kind of limestone source. But it's about not digging more material from the.
Oh, no,
Any more questions? Yeah? Thank you.
Is it? Oh, okay. So I was just going to ask a question about LITAG, because I suppose you both work for aggregate industries. You know, LITAG was not only a circular product, but also a pretty good product. So I heard. So you know, what's happening to it now? Because we know that it's going to be incinerated, so it's not necessarily low carbon. Yeah, just wondering if there's new development on that or replacement for that.
I mean, for LITAG, the plants has closed down, yeah, and we do not have let's say immediate solution for replacements of the material apart from the alternative lightweight aggregate materials. It had, yes, relative high carbon footprints, and yes, despite the fact that it was reusing some material landfills, fly ashes. Maybe this is a better use for it as a silica corrective, maybe, or as a EN450 fly ash if it's treated in a different way.
Okay, I think we're up at time anyway, so if there's no more questions, I'd like to wrap up if that's okay. And thank you both once again. Thank you.